Welcome, everyone. We're very excited for you to join us today. We have Eric Shreve and Melissa. I have already messed up your last name. And so I'm going to let her introduce herself again. So this is the, the ADOT and One Spatial solution for Arizona. So I am excited to have them here. Eric, do you want to kick us off with some introductions?
Absolutely. Thanks, Jenna. Good afternoon. Hope you're all still with us. I know it's been a long week, but obviously we have one of the more exciting topics saved for the end of the session as a whole. So if you've not met me, my name's Eric Shreve. I work for the State 911 program. We've been involved with NextGen 911 for several years now. Program went through somewhat of an overhaul over the past couple of years, and we've been pretty aggressive with moving forward with NextGen 911 implementation. The thing that we're going to be talking about today is a solution that we feel is going to really help the local data contributors as well as the 911 operational professionals that are essentially going to be using that data for geospatial call routing. So again, I hope you find this of interest and look forward to hearing about questions and comments that come out of this. Pass it off to you, Melissa.
Hello, my name is Melissa Obaldo. I'm a solutions engineer at One Spatial. I will be demoing portions of the submission, data validation and submission portal that Eric and his team have actually set up to help their data contributors streamline the data supply chain for NG911. Nice to be here.
All right, let me share my screen. Okay, can you see my screen slide deck?
Yes.
Okay, so just kind of a quick overview of what we're going to be talking about. Introductions, we already went over that, but going into more detail about just kind of the overall process and where we stand as we move forward. Disclaimer, Jim Myers could not attend the meeting. So as far as any sort of ADOT or DOT type questions or inquiries, I can defer to him or follow up with questions, but he wasn't able to attend. So just letting you know about that. So kind of a quick background, as I stated at the beginning of the presentation, the state has moved forward with NextGen 911. We procured a vendor referred to as Comtech for NextGen core services, which that brings is both the ingress and egress of 911 traffic. So you can essentially think of it as an IP-based network to support emergency call routing. One of the big elements that comes out of NextGen 911 is GIS. So traditionally today, when you place a call, it's triangulated off a cell phone, and that's a determination that where your location is at and what resources to respond. Not the most reliable process. So with that, NextGen 911 came forward, which placed a heavy dependency on address points, road center lines, as well as the various polygons referred to as PSAP, ESB, emergency service boundaries, which are composed of fire, law, EMS, and then provisioning boundaries. Those are the core data sets that are required for NextGen 911 to be fully implemented for geospatial call routing, which is essentially an I3 standard per NENA, which is the National Emergency Numbers Association. They create all the requirements and standards, the best practices. Just kind of moving forward, one of the previous workflows that the state of Arizona implemented was working with Terra Systems Southwest. So Howard Ward, if you haven't met him before, he's a great individual, has a lot of innovative ideas and solutions that come to place. And essentially, he was supporting the overall process for E911, which was referred to as Enhanced 911, to support a product that was referred to as Vesta Map Local, which was essentially a call mapping aspect of the 911 systems for the local localities across the state. So, and essentially what that process looked like was biannually, email would go out, a solicitation essentially to the 15 911 systems for the core GIS data sets. And then he would go through his process, manual iterative process of appending the data sets, cleaning out information, making sure that consistency when we're talking about the NENA I3 schema was met. There's a lot of requirements, as I said, that come with that. So very lengthy process, but overall, it was something that the state could utilize for that process that we refer to as E911. Pivot off that, beginning of this year, we essentially looked at procuring a solution that was more automated, that would have more of the ability to streamline this overall process. One of the requirements, or one of the initiatives that we wanted to do based upon that, was that discrepancy error reporting. So you can see that fourth line, discrepancies resolved at least 72 hours. So per NENA and the recommendations that they provided at a national level, they are telling 911 systems or PSAPs that if there's any discrepancy with a road center line or address point that doesn't have the ability to route correctly, that error needs to be remediated within 72 hours of that report. So obviously, when we're talking about a manual workflow and putting a lot of reliance on just using basic desktop tools around ARC desktop, it doesn't really offer that flexibility that we want to see for something a little more dynamic. So hint, that's why we went with the solution that we're going to be talking about in a little bit. And then the other thing is significant coordination across the systems or jurisdictions. These are referred to as 911 systems, which more or less are counties. And then they obviously interact with the local municipalities across the state. So I like to refer to it as cat herding. That's essentially what we're doing. We're working with the data providers. We're making sure standards are met and requirements meet the specs for NextGen 911. So again, this is the disclaimer that I provided at the beginning. I can't really give a whole lot of background knowledge on ADOT's business need, but essentially what ADOT is using today is a process known as ARNOLD, All Roads Network, linear reference data. And essentially, that's a requirement from the Federal Highway Safety Administration that every state DOT needs to report every public road center line to the federal government for funding, essentially, for their program. So one of the concepts that we looked at leveraging was through AZGeo, which essentially, that's the statewide data repository that we're using that any, form of government, local, on NGO, et cetera, can have access to. We looked at that as essentially as the data repository. So the days of relying on an FTP server or emailing data or shapefile or file geodatabases back and forth, we just didn't really see the capacity going that route. So that's where we relied on AZGeo to help streamline that process. And then essentially where ADOT came into place was they saw an opportunity that, ADOT is already making these requests to the local data contributors as well as 911. Why don't we parallel efforts and form some sort of partnership where we can aggregate that data for both needs for DOT as well as 911? So at the end of the day, it's a collaborative process that we're looking for between the 911 office, ADOT, as well as Arizona State Land Department. And, one of the things that I really want to stress is that we want to try and do as much reduce of duplication as possible. So, the duplicate data requests, the duplicate appending of the data sets. I mean, there's a lot of processes that go on the back end that essentially have to be put in place to make this data standardized as much as possible. And then lastly, at the end, Shay touched on this at the beginning of the symposium, but we're really trying to expand the use of the statewide address geocoder that's utilized through AZGeo. Trying to have the ability to use more of an authoritative data source for people to do their business process. That's one of the end goals that we want to get out of this. So I'm going to talk about this workflow, and Melissa, feel free to chime in if you have any comments. So during the requirement phase, that's the part where essentially, you're either moving in the right direction or the wrong direction when you're trying to procure a solution. So looking at a workflow similar that the state of Michigan implemented for their program, we came up with this workflow of this concept of change detection as well as change proposal. So it's a concept that rather than submitting data continuously, going through the QC check, going through that repetitiveness process, why don't we implement a way that we can do some sort of transactional update? So if there's a change in, the address point or road center line, rather than going in and going through that process of appending and cleaning out the data, why don't we just read through the data, and then if there's any changes that's occurred either from a spatial or attribute perspective, it'll be applied, and then it takes into consideration that overall statewide data set. So it's kind of a little bit unclear when you're reading through this. The slide deck will be provided afterwards, but it just kind of talks about how you get from step one to the end goal, essentially. And then the part I didn't talk about is the integration of the data sets for our NextGen core services. So that's essentially taking that statewide data set and wrapping it up into something that can be consumed by the spatial interface, which is essentially the opening part when you start to submit data to a NextGen core service environment. That's a whole nother discussion that I could go on for hours about, that we just don't have time to cover. Melissa, is there anything?
No, because I feel like the demo will actually be able to speak, will be able to describe the process better, and actually be able to give our data contributors or whoever other stakeholders for your portal would be able to kind of see how this would be falling into their current workflows. But everything you said, oh, sorry, go ahead.
Oh, I was just gonna talk on this really quick, and then I'll kick it over to you for the demo. So just to kind of add on to the requirement gathering. So it was a lengthy process that we did working with our partners to essentially strategize what we wanted this solution to do. So, some of the basic requirements was that per our directive with ADOA, Arizona Department of Administration, we're working towards a cloud-first mentality. So something that has the ability to scale, that would essentially help our stakeholders at the end of the day. And then in addition to the ability to authenticate through AZGeo, Melissa will show that in the workflow. So the single sign-on process of having one password as opposed to many passwords. And then one of the other things that we really liked out of this was the ability to report out analytics. So if I need to show a stakeholder that might not necessarily have the knowledge of what GIS is or what a geospatial framework looks like, I can present data that shows essentially this is what data quality looks like for a given jurisdiction, and I can show that progression over time from this is where we initially started with the application and this is where we stand today, showing that that the KPI, essentially key performance index, of what the overall data integration and data quality looks like as we move forward. And then lastly is workflows with ADOT. That was one of the things that we really wanted to do to reduce that duplication, as well as streamline efforts that would help people at the end of the day, as well as not frustrate them when we're talking about repeating workflows and repeating processes. So, okay, I will kick it to you.
All right. Thanks, Eric. So before I actually walk through the demo, what I want to talk about is what's about to happen in the demo. So I'll be showing you the process in which data contributors can use the One Data Gateway validation and submission portal as a tool to obtain, first and foremost, a clearer assessment of the quality of their data against a set of standards and business rules. And second, be able to identify where and why their data have non-conformances or have failed to meet certain rules. So because all of these are, again, based on rules, what we're looking for is data conformance. That is how we are able to assess the quality of our data. So with that, let me go ahead and share my screen. And oh, it says you have to stop sharing it, Eric. It says I can't grab it from someone already sharing.
Let's see. I'm trying to bring up my controls. Let's see. Let's minimize that. Sorry for the delay. Jenna or Brian, do you guys have any?
I don't have the controls, Jenna does.
You guys can help out on that. Trying to find where my
Yeah, I'm more.
meeting control. There we go. Okay, Melissa. Sorry about the delay.
Let's see here, my screen. Share.
There we go.
Hello?
Yep.
Oh.
Yeah, you're good. Oh, it went away.
You had it. It went away.
No, I saw it and then it just, here we go. And I'm turning off my video because I think the bandwidth is affecting how smoothly this is supposed to look. All right. Alrighty.
There we
So
go.
hopefully you're seeing it. This is One Data Gateway, and we've skinned it to how Arizona currently has it or wants to deploy it for the people who would like to share data with them, simply put. So like Eric said, one of the newest features that we've incorporated into this is letting everybody or giving everybody access using their ArcGIS Online accounts instead of creating a new username, a new user password, et cetera, et cetera. We all know how much of a headache that is. So that's part of the things that we'd like to streamline here as a process throughout the data supply chain. So what I'm going to do is go ahead and say sign in. Let me just plug in my information there. And as a data contributor, what I see in here are assignments. The assignments are the various data validation workflows that have been set up for me by Eric and his team, and saying that if you want to check on your data quality of your data, go ahead and run them through these different workflows. So let's say that, again, like for me, not really knowing what these rules look like or what these workflows are actually doing to my data, I'm going to start by saying, okay, today I worked on my roads. So what if I want to run it through the rules that Eric has, I keep saying, but the ADOA has set up for me to run through. So I'm just going to say I worked on roads today and say, what can I do with my roads? I can run cross data validation checks, like with site structure address points, with MSAG as well. I can run NINA checks, of course. I can run it against boundary layers. I can also run it against other road center lines. So all of these, by the way, these are not it. I mean, it will be a growing list or a growing workflow catalog. Like it's going to be, right now, what we're looking at is actually the dev environment, I think, Eric. So it might actually look different when it's been deployed. But for all intents and purposes, let's say it does look like this. So let me go ahead and say, let's just run an essential geometry check here. So it says here that the essential geometry check, actually, let's go back and read that description real quick. Validations organized throughout rule conformance can be solely reported. I clicked on it. Can be reported solely for the road centerline layer. So I don't really know what essential geometry checks is, but I know that it's one of the first validations that I would like to run my road centerlines on. It's one of the better workflows to run versus running it as a cross feature check, running it with MSAG or site structure address points. I want to know the base data quality of my road center lines. And I know what the essential geometry checks are because I've worked on these rules, but what they essentially are is they are meant to find out the very common geometric issues in your data. And for everybody in the GIS realm, everybody knows that sometimes there could be kinks in there, spikes, kickbacks. You can create duplicate vertices, multi-part geometries. You can even create null geometries or introduce null geometries in your data without really knowing it. So it's part of having all these different automated processes in the different environments that we use for our GIS data. But anyway, I'm going to go ahead and say start a new submission here. And I'm going to say, let's go ahead and submit my road data. So I have a sample of Graham Streets here, drag and drop, and I'm just going to say hit continue. So what's happening here is it's trying to read the data that I submitted versus the data that it actually is expecting. So let's see here. My data set contains a source class called gram_streets, but I'd like to submit that as the expected feature. It's been set up this way. So at this step, let me just click here. It's only expecting 2 attributes. So it's saying, give me a unique ID and make sure that I have a geometry in here. So right now there's only 2, but of course for our NINA validation, you would want this in the data would be expected. The workflow would expect you to have your data in accordance to the NINA GIS standards. So what's nice about this step is that me as a submitter for gram streets, I don't have to have it exactly the way that the NINA GIS data model has it. But what I can do is, because I know my data, I was the one who created this data, I was the one who worked on it, I can go ahead and map this attribute right here to what I think it should be submitted as. And that really gives, it empowers me to be the one to decide how my data gets through. And it's really nice to have that step, to have me as a data contributor be in charge of that step. So right now, again, there's only just 2 of them, but what I can do is I really only need to do that step once, mapping it across from source to target, because at the top here, I can actually say manage schema mappings and save that mapping for next time. So that next time I make a submission using my username, because I'm logged in as me, it will automatically map all of those for next time. So I'm going to scroll all the way down here and just say continue. I'm saying that everything looks good, and it essentially kicks off the workflow. So while we're waiting for the data to get read in, to be read in completely, which is what you're seeing in here to load the submitted data, let's go ahead and take a look at what these rules are, the tasks that make up the workflow of the essential geometry checks. So right here, it says, check that features are valid, check that features are simple. And one of the things that we can do here, and it's probably because, again, I was part of the team who wrote these rules, the definition of what valid is and the definition of what simple is are according to the OGC standards. So that's one of the things that, for example, if I have roads in my data that are failing these rules in particular, I can ask Eric or whoever else and say, hey, I think I need help with this rule because some of my features are failing it and I don't really know why that is. But let's look at more rules here while that's running. Check for multi-part geometry, check for self-intersections. Again, very common geometric dirt, as I like to call them, in GIS data. So what you're noticing here too, yep, it's all finished, but let's scroll back up because what I want to focus on is what we're seeing here as this process is rolling. Again, because these are rules, we are looking for conformance for their features. So I brought in 3,626 features, and that's running through everything. Clearly, we're seeing here the total number. And we're seeing here where it's marked green to say 100% of all of the streets that I submitted passed the rule that says check to see that the features are valid. So in contrast, we have here where it's red. It's giving me a 99.97% conformance rate because I have non-conformances in my data. And that's in the form of just one feature in here, because of the 3626, it says 3625 passed the rule. So that's where that conformance rate came from. So one of the things you're noticing through here is that when something has failed, we don't just want to know that it exists in the data. You, of course, want to know which one it is and be able to navigate to it so that you can actively correct it. So we're seeing here an action that it actually marks up all the different it marks up every instance of an error that is spotted. So let's unnest that. So of all of the checks here, the data is relatively clean. We really just have that one feature with the multi-part geometry. And the multi-part, of course, would mean that if you select the geometry, it consists of more than one part. And that could be an issue for routing, for example. All right, at the end here, we are seeing just some actions that are summarizing all of these issues. But what we really want is this export right here at the end, where it says, after running all of these features, or all of these checks, sorry, I ended up with 2 markups. That's for the occurrence of our multi-part geometry. And on a summary of my markups, it says there's an indication of 1 because it's reporting that 1 instance of a multi-part in my data. So what I want to do here is, again, I don't just want to know what that looks like, or I don't just want to know that it exists. So there's actually a cache map viewer in here that I can show you real quick. And I'd be able to see some of those errors by zooming in and out. This is by no means meant to, replace your GIS applications. It's just a nice, quick sanity check for making sure that the data is actually running, or the workflow is running as expected. But what I want to do is, again, I want to be able to get that export because it says that it marked something up. So I'm just going to hit continue, because at this step, I'd be able to see that I can download that output right here. So essential geometry check markups, I'd be able to hit output and be able to download that file. I can also get a copy of what I just submitted. One of the other things here before we move away and actually take a look at what that exported file looks like, there's an auto-generated PDF report right here as well. And what it does is gives me a copy of everything that we just ran. So it says I ran your road centerline validations, essential geometry checks for roads. This is when I did it. This is how many features I submitted. This is how well it ran through the validation workflow. And at the end, how many did I have to go back to or revisit so that I can, how many things did I have to clean up before I can say that this data set is 100% clean. So it's nice to keep these metrics on hand if you want to download them for future reference. I think before we move away from this interface and take a look at those markups, I actually want to go up here and show you, because we're on the topic of metrics, is not only am I able to see a submission history of all the times that I made a submission, I can visit what I did yesterday, and I can download at any time the input and the output from that particular run, view that report right here, and be able to see that nice conformance rates right there. Easily access it. Information tab, which it can be populated with information about what these rules look like, as an example. But what I really want to show you is the dashboard, because I can keep track of how well I'm doing as as a data contributor. My top violated rule is check for multi-part. This is how many times I've been submitting my data throughout the history of, or the range of dates that I select on here. And here at the bottom, if every time I resubmit, am I actually improving? And you're seeing it as a straight line because I've just been submitting the same test data over and over again. But ideally, you probably see it over here and start trending upward, because one of the things that we want to see here, of course, is that every time I resubmit, I'm actually improving and cleaning that data to get it at 100% conformance. All right, so I'm going to go ahead and switch over to ArcGIS Pro as more of just as a viewer of all of these of my markups that I just exported out. So hopefully you're seeing right here that I have a sample of the streets from Graham and some address points. And this is what that markup looks like. So in here, I'm just going to go ahead and zoom in. And what I want to show you is, oops, here we go. We're seeing here that there was a markup created on this particular segment of street and this particular segment right here. It tells me why this has been marked up, because it's failed the rule check for multi-part. And it tells me there's a comment in here that it's part of a complex geometry. It tells me the feature ID. And one of the things that we can add here, and I would encourage, maybe more ideas on how to make these markups more helpful as a reporting tool for me as a contributor. Because one of the things I do want to recognize, because I have had these conversations with a lot of different people from different states, is that not everybody who is working on this is a GIS professional. And we don't really, I guess, expect everybody to know what to do with their GIS data, especially when it looks like this. So, if there are specific tools, there are specific configurations that can help me understand what's going on without knowing that, topologically what's going on, then that description can definitely be part of that reported markup features. But this is just how we have it as a default. So selecting this street, let's just confirm that on this private copper circle, if I even just select this geometry right here, it's consistent of 2 parts. And one of the things that you can do here, of course, is explode them so that it's not just it's not a multi-part. And actually, before I move away from this, is I also want to say that sometimes there could be exceptions to our data, and again, those are one of the things that I feel like Eric would want to and would like to encourage people to say, if everybody is a subject matter expert of their own localities, so the more people are a part of how of the improvement of this workflow of all these different validations, the more useful it's going to be. Okay, so that's just how it looks like. That's just one of the examples, but I actually want to look at what other types of validation are there. I do want to touch on maybe a cross-validation. And apologies if this is a little too complex, but I just wanted to kind of show what other things can be processed and how can that information be relayed across to people who are submitting their data set. So let's say that my road center line is already clean. And I'm saying, okay, it's clean enough. How about let's submit it to run a cross validation with another layer that's existing in the data set. So in here, what's happening here is we have site structure address points that we would expect to be mapped to a matching road center line, and it's creating fishbones in there. So what we should see is just one single fishbone neatly across, touching to one road center line. But one of the things is, just because it was mapped across doesn't mean it's correct. So just as a quick preview here, you can also mark up there could also be markups that are provided for the users here. And just to, again, just kind of illustrate what these markups could look like. It's telling me here that the address point I have maps to multiple road center lines, and that's why I'm seeing my fishbone lines marked up, or it's violating one of my rules. So anyway, my point really just for that is that there are more things like outside of Nina that Eric and his team are working on to get this NG911 solution. And again, the reason why we have the NG911 solution look this way is because of people, probably everybody on this call, everybody on this call who are part of the conversation and want to contribute on how this particular workflow for NG911 would be most helpful to them. Another process and another workflow that's available for the NG911 solution package, which is what we saw in the One Data Gateway, is change detection. I'm not going to run it live, but it is one of the ones that will be included in the package. So change detection here, of course, what we want to do is be able to detect changes. If we kind of recall back on the diagram that Eric showed us, we saw that there would be a part where change detection proposals would be processed and submitted and processed by on the back end before it gets rolled up into the NG911 main repository. But essentially what that process does is it takes your submitted road versus what's already existing in the repository. So it's saying, before we introduce these roads, because I'm saying I updated my area, let's take a look at how that's different from what's already existing in the data. So one of the processes here is that it will actually create proposals to say, this is what the rule has detected as a change between 2 vintages of road data. So I did turn on a road centerline 2018 in orange and a black road centerline 2019. And just a preview of how some of these changes look like. Some of them are adds, deletes, extensions, etc. Let's take a look at what some of those look like, because I want this to be able to help me. So when I'm able to download a copy of how these proposals look like, I want to be able to understand how I can improve my data for next time. So let's take a look at an example. Oh, this one's a pretty obvious one. So just a quick peek in here. So we're seeing our orange line is getting extended right down here. And not only that, we are adding a new line. So when we get a copy of how these changes are flagged using the One Data Gateway portal, let's just select that real quick. This guy, of course, is getting added. That's a change that being proposed. And it's saying that this line right here is getting extended. So the reason why you're seeing multiple colors is that there's a segment right here that we're saying should be retained, because we want to be more specific about the geometric changes that we're seeing here. Let's take a look at another one. In here, it's pretty obvious, kind of. We're seeing that the road has now been split. So there's a change in there that's saying the road should be split and should be updated. Let's take a look at one that is non-geometric. I think I have one in here. Here we go, scalar update. So this got marked as a scalar update. Scalar meaning it's an indication of a change in attribute as opposed to geometry. And the reason why this got flagged is because a very tiny detail in here, the name actually, the road existing on the data set has a dash between these two last strings. And in here, it's being updated to not have that dash. So one of the things that I get asked a lot too is maybe we can make some sort of exception to the rule. So that's definitely something, these types of configurations are how to customize how these rules accept these changes or not. Again, that's something that can be discussed and changed, because this is not a product that's deploy it and it's done. We definitely want this to be a more collaborative, and like Eric mentioned, they want more people to be able to engage in it and be part of how this NG911 data supply chain actually gets rolled out. So before we move away, I'm not sure if there's another thing that I want to show here. Oh, well, I guess that's it. Again, just a quick history of which ones I'm submitting. I can take a look at what I've done beforehand. And yeah, I think that basically covers it, Eric. I'm not sure if I missed anything.
Yeah, I was just going to add, so this interface, when this does get deployed, which we're looking like mid-November, the counties in essence will have their own ability to see a supply. Essentially, you can think of it as a county as a data supplier. So they'll have their own ability to essentially segment, where they're doing their data validation checks. So just going to add that. Great. I will take the sharing ability back. You there, Melissa?
It's frozen.
I have it back.
Is it okay? Great. Yeah.
All right.
Something funny. Okay.
Appreciate it. Thanks again, Melissa. That was an excellent demo about just seeing the capabilities. So I'll just kind of wrap up, our overall discussion here today, and just kind of summarize what we've been talking about over the past 30, 40 minutes. So kind of just stepping back a little bit, talking about the overall strategy of why we went this direction and why we went towards one spatial in particular, was kind of just the overall process of streamlining efficiency. I think of, a lean management concept when we're talking about data curating, data maintenance, authoritative information. And I think overall, if the workflow that we're going to be implementing with the counties and 911 systems has that overall strategy and overall ability to kind of make the information not necessarily uniform, but standardize it so we don't have inconsistencies. I know in my workflow, obviously having standardized data sets as well as accurate and updated information is significant. I think it was either the AZGeo session or the day one symposium. I think I heard an individual saying that, we need to have a better ability to update data, as well as, having the capability of having effective metadata, essentially. So we know what am I using? What am I implementing? So, all in all, that's kind of the overall strategy that we went with, working with ADOT, 911, and Arizona State Land Department. And then in addition to using our existing infrastructure, which is referred to as AZGeo, that's one of the real big takeaways. So we're not, investing in going out and procuring new solutions essentially to house and act as a data repository that everyone can essentially use. So kind of just touching on what the business case looked like. Obviously, NextGen 911, that's one of the more critical pieces that we're looking to support, the linear reference data that ADOT is utilizing, as well as the national address database. So that's essentially another ability that we can utilize data quality checks when we're, aggregating this information for a statewide data set. That's another ability that we can use. And as well as that, national address database supports a federal initiative to look to standardize and have consistent data, so we're not doing the duplication that we're talking about. Noted the statewide geocoder previously, and one of the discussions that we've had, this is high level, it's nowhere near implementation, but talking about how do we integrate parcels. This is a common request that we get from either counties, localities, you name it. I've been in this position for a little over a year now, and I think I've lost count of how many requests I've received for parcel information. So one of the abilities that we're looking at through our state statute for 911 and working with our legislative folks is having the ability to put parcel information as one of the required data sets. And essentially we would have the ability to incentivize some of these counties a little more than how they are structured today. So that's something that we're really excited about. And obviously it's not close to implementing, but discussion about it is happening internally. So just kind of wrapping things up, the biggest thing that I believe in is having the ability to form relationships and partnerships with the counties and, let them provide areas for improvement as well as ways that, the solution can either help their workflow or help someone that they know is struggling. So I'm a big believer in this overall workflow that we're looking at with One Spatial and how it supports NextGen 911 is open for interpretation as far as how we want to define it. Obviously, the baseline for NextGen 911 and how it supports ADOT with their business needs, those are the requirements we have built in place that have been implemented. Again, that will be mid-November. But obviously, we want to leave the discussion going forward about how do we optimize this tool? How do we have the ability to streamline the process in general so that if I'm a local data contributor from Mojave County, I have a process that I feel comfortable with where I can upload data and to pivot that, let's say I'm, a large locality or municipality or county like Maricopa County or City of Phoenix. And, I just don't have the resources to do data validation as well as, that data quality that we want to see. We're really just, having that opportunity to provide this tool set for the counties. And I saw in the chat that there was a question about getting local agencies involved. That's definitely something that we're looking at as another opportunity to get those local data contributors that are under the county to provide and have the ability to do their own data QC checks, essentially, have them the ability to enable themselves. And then lastly, the return on investment, ROI. This is always a difficult one to capture in government, but I'm a big believer if you have the ability to capture metrics that show either a cost saving or efficiency all around, that you can get buy-in from that executive leadership to make improvements, support things going forward. So, that's one of the big things that I really believe having the data analytic capability of One Spatial and One Data Gateway is going to really bring to our value and our customers, as well as just kind of making Arizona a greater place. So with that, we wrapped up a little early. Again, here's our contact information. Feel free to either email me or give me a call. I am always open. I always I always set time aside to have conversations with people, Jim as well, and then Melissa. And with that, do we have any questions, Jenna or Brian?
We do. We have a couple questions. So one of the questions is, are you going to ask counties and overall CL contributors, I'm not quite sure, centerline contributors probably, to upload their data annually or at another cadence?
So the cadence right now per NINA is 72 hours. That's obviously a workflow that we're working with our NextGen core service provider that is going to be another addition to what we're talking about with OneSpatial today. Ideally, I would like to do a monthly update through our NextGen 911 language, essentially, for how we define our legislation and statute. So obviously, it's putting a requirement on the counties and local contributors, but at the same time, we're working on language and updating our statute to reflect more funding, essentially. So rather than, a one-person shop in a county that's wearing multiple hats and they're essentially being asked now, hey, you need to update road center lines every month. We're looking at ways and how we can provide more resources to help out with this geospatial effort, either contractually or looking at the state office to do it internally. We have a couple options at play that we're researching on as the best solution.
Great. There's one more question, Eric, and that is, let me get it up. What are the benefits of using OneSpatial change detection tools to find changes in center lines rather than the Esri detect feature changes tool?
So I would say the reason why going with the OneSpatial concept or solution, why that's an improvement over the Esri, is that it standardizes the effort as a whole. That way, you don't have disparate workflows. Obviously, not every workflow is the same, but at the end of the day, we're really looking for ways to standardize this whole process and workflow in efforts to make sure data is consistent. I haven't used the Esri detect feature on my end, so I don't know what the capabilities are. So, for all I know, it may not have the ability to meet the requirements for what NINA would have. So, if you're going through that process of doing a change detection through a desktop, ArcGIS desktop, it may not offer that ability to do the requirements that you would need for NINA.
May I also add something to that, Eric? I mean, that was was a really good answer. But I did just want to ask and speak on the side of OneSpatial product is that you don't need to be and this is, I guess this is more on the people who are building these rules or are able to make those changes behind the scenes, which would be Eric and his team. But these rules aren't, again, they're not one and done rules. These are not final rules, because again, we want to be able to make sure that all of the concerns of the different localities are taken into account. And I think that I feel that that's why Eric is also encouraging the collaborative effort, because we want to make sure that if there are any idiosyncrasies on other people's local data, those things are actually those things are reflected on how these workflows are built. And on the side of Eric and his team who can change these rules, they don't need to be programmers to write these rules. And I'd be more than happy to entertain anybody else on the call for a quick demo and kind of take a quick peek at the engine under the hood that's running behind the scenes, because it's definitely it's way more powerful than just the NG911 stuff. I mean, of course, the NG911 stuff are very, very important. But one of the things that I do also want to mention is, like Eric, I've never used that tool for ArcGIS, for the Esri tool. But one of the things that I want to clarify is just really the configurability of it, and how to Eric's point, how they want to make sure that things are standardized, because this is easier on the people who are managing these rules and workflows behind the scenes, because they really only need to build one workflow one version of a workflow, and that would be the same workflow for every single person who would like to submit their data and run their data through it. Again, it keeps that environment controlled, and it makes sure that the same high data quality standards are met each and every time that data is run through those workflows.
Thanks, Melissa. That was great.
Excellent. Thank you both. I think we're going to be able to give folks a few minutes of their day back. We're almost wrapped up for the AGIC symposium. We still have the hospitality suite tonight, and we also have meetups tomorrow. So I hope you are able to join us. And thank you very much for joining.
Thank you all. Appreciate it.
Thank you.